Alphabetically, aircrack is the first tool listed in the wireless attacks menu. But it's also one of the first tools we should try to learn when dealing with wireless networks. Aircrack is really a suite of tools aimed at assessing wireless network security. The tools focus on monitoring, attacking, and testing and cracking keys. But before we dive into the tools, let's first talk about how wireless clients connect to access points. Then we can dive into how we can capture wireless traffic and crack WPA. There are two phases we need to talk about when clients connect to access points. First, there's the association of a client to an access point. Then there's an authentication between the client and access point that allows for encrypting traffic. Let's talk association first. This process is similar to plugging in an Ethernet cable and then the network doing all the negotiation before providing network access. The first thing is the client sends a probe request to discover networks within its proximity. Embedded in a probe request are advertisements that detail what the client-supported data rates and 802.11 capabilities are. Because a probe request is what's known as a broadcast, all of the access points that are in range receive it and will respond. Access points receiving the probe request will check and see if the client has at least one common supported data rate. If they have compatible data rates, a probe response is sent advertising the SSID or the wireless network name, supported data rates, encryption types, among other things. The client chooses compatible networks from the probe it receives and responds. The client then sends a low-level authentication frame to the access point. The access point receives the authentication frame and responds to the client with an authentication frame set to open. Keep in mind that 802.11 authentication is not the same as WPA2. 802.11 authentication frames are open and almost always succeed. Once a client receives the authentication response and determines which access point it would like to associate to, it will then send an association request to that access point. The association request contains encryption types if required and other compatible 802.11 capabilities. The access point will then create an association ID for the client and respond with an association response with a success message granting network access to the client. Now the client has successfully associated with an access point and data transfer can begin. Next comes the WPA authentication process, or the four-way handshake between the client and access point. Don't worry if you don't grasp all of the terminology right away. We are just talking concept and how it leads to cracking a pre-shared key. So the client and access point each attempt to prove they know the pre-shared key, or PSK, without outright disclosing the key. Instead of disclosing the key outright, the access point and client encrypt messages to each other and can only be encrypted using the PSK they already share. Take note that the MAC address of the client and access points are integral to the process. A MAC address is an identifier that's unique to all network devices. It is how we distinguish one device from another. Okay, so let's talk about the actual handshake process. The access point transmits an authenticator number used once, or what's called an anonce. It's a random number that is going to be used to build an encryption key to the client within the first handshake packet. The client then creates a random number called a supplicant number used once, or SNOTs. It uses that number, the pre-shared key, the anonce, the access point MAC address, the client MAC address, to generate what's known as a pairwise transient key, or a PTK. The client then submits its SNOTs and message integrity code, which is used to ensure the integrity of the data to the access point. The access point now has the anonce, the SNOTs, MAC addresses, and the pre-shared key to generate its own, or generate the PTK itself. If all of the information matches, the PTK on both sides will match. Next, the access point constructs what's called the group temporal key, a sequence number that is used to detect replay attacks, which is an attack in which a valid data is maliciously repeated to the client and sent to multicast and broadcast traffic. It also sends a message integrity code to the client. The client then installs a key, and lastly, the client sends an acknowledgement number to the access point, verifying that the key is installed and it's got all the right information. Now, the astute among you may have realized that the four-way handshake, you only need the first and the second packet of the handshake to be captured. An attacker then has enough information to compute the pairwise transient key and then compute the message integrity code. Okay, let's start with Ehrmann. Ehrmann is a tool that puts your wireless interface into monitor mode, and it allows your system to capture the wireless network traffic floating around. If you just type in airmon-ng, you will see that it shows you the compatible wireless interfaces available to your system. You see here that it detects my alpha network card with a raw link chipset. Note that the interface here says WLAN 0. So here we want to do an airmon-ng start WLAN 0. You'll see here that it's starting to put my network card into monitor mode. It'll also show you some potential services that could cause a conflict with monitor mode, but we'll just ignore that for now. Now, if we do an airmon-ng again, you'll see that the interface is now WLAN 0 mon. Now let's run airodump-ng WLAN 0 mon. This command shows you what your wireless network card is able to see in your immediate area. The BSSID is the MAC address of your wireless access point. Note that the power field gives you an idea of the signal strength for each access point in the area. The closer this number is to 0, the stronger the signal is. The CH field tells you that the channel the access point is operating on. The encryption field tells you the type of encryption each access point is using. So you'll see WPA2, you'll see some that are open access points. The authentication field tells you that they're using pre-shared keys, so these access points are each using pre-shared keys. The open ones have no authentication field. And then you'll see the ESSID is a wireless network name. Note that the ones that say length 0, these are the hidden access points. We still see them, but we don't know the name of the network. What immediately catches my interest is an access point called Netgear 004. Right here. I know this is the default naming syntax for Netgear for its wireless networks. I also know that the default pre-shared key for Netgear uses a predictable format that has an adjective, then a noun, then a random 3-digit number. So I only want to focus on this access point. So I'm going to grab the MAC address associated with it right here. And then I'm going to cancel out of airdump. So now I only want to focus on that particular access point. So I'm going to do an airodump-ng/C for channel 11, which I see right here. I'm going to write to a file name called Netgear 04, and I'm going to focus on BSSID, that MAC address I copied earlier. Oh, let me copy it again. have an extra space in here, so pull that out. And then I'm going to specify my interface, WLAN 0 mon. Now you see I'm only watching this access point. I can wait patiently for a client to join the access point to capture the four-way handshake, or I can actively knock a system off the network and watch it rejoin. To do this, I'm going to open a new window and run the airreplay-ng tool. So I'm going to run the command airreplay-ng -0. -0 means it's going to send deauthentication packets. I'm going to send 5 of them. I'm going to specify the access point. Here I'm just going to put in the MAC address again. Got a trailing space again. And then I'm going to specify the interface WLAN 0 mon. Now you sending out deauthentication packets. Now notice here, it tells me immediately that it's captured a WPA handshake for this access point. So now we can try to crack it. I'm going to close out of here. Now I'm going to open up aircrack-ng and feed it a list of potential pre-shared keys to see if we find a match. I'm going to use my Netgear word list that has all the combinations of adjective, noun, and 3-digit numbers and try to brute force it. The command I'm going to use is aircrack-ng-w. This is specifying the word list that I'm going to use, which is located in user, share, word list, and then word list, and then Netgear word list. I'm going to specify the file name that I used, which was Netgear 04-cap. And then it's going to run. It's using the word list I downloaded from the internet using the Netgear word list. And you'll see immediately it tells me that it's found the key, Ancient Butter 271. So the lesson here for attackers is to try to find the low-hanging fruit. A lot of people don't realize the dangers of setting things up as default and don't realize that malicious people can discover these things and exploit them. For defenders, you have to understand the methodologies that attackers are using and realize that running systems with default settings could leave you open for exploitation. At all times, use complex passwords that aren't predictable and cannot be found in a dictionary. The longer the password, the more infeasible it is for an attacker to guess it or brute force it.